So, yesterday we were talking about our percent increase and percent decrease problems when we're given some number and a percentage, right? So last week we were working on problems where we were given two numbers and had to find the percentage. This week we're focusing on finding one of the numbers rather than a percentage. So to do that, we were using this equation right here. Today we're going to practice this equation a little bit more and maybe introduce our markdown equation. Does that sound like a good plan? Cool. So let's just go ahead and run through a problem really quickly, refresh our memory on how to do this, and we'll get rolling. So let's say let's say I really love baseballs, and I have all of these signed baseballs from some really cool baseball players. So let's say I have 30 baseballs in my collection, and I purchase some number of baseballs, and my collection increases by a size of 15%. And what I want to find is the number of baseballs that I now have. Okay, so this is our equation right here. What would be our first step in trying to solve this problem? Okay, so with that sort of problem, the process is exactly the same. How close the numbers are doesn't really actually matter that much. Yeah, it's the same exact process. No matter what numbers we're given here, right? This could be 2 million and this could be 2 million too. I mean, they can really be any numbers, but our process is going to be exactly the same. Does that make sense? Okay, cool. That's a really good question. Okay, so what would be our first step in trying to find the number of baseballs that I now have? So 1 plus, what's another way that I can write 15% as a decimal? That's exactly right. Times 30 equals our bigger number. Good. Okay. First step in solving for this bigger number right here. Times 30. And 1.15 times 30 is equal to 34.5. Now, does it make sense to have half of a baseball? No, it doesn't, but sometimes this is something that just happens because we did the math right. 15% of 30 is 4.5 or 4.5. So oftentimes I saw your teacher, he wrote just round to two places. So in this case, we can round this number. Would we round it up or down, this 4? Okay, why do you say down? Okay, so what we look at is the number that's to the right, this number right here, and if this number is greater than 5, we round up. If it's less than 5, we round down. Does that make sense? Cool. So we have 35 baseballs, and good. So now we're sort of familiar with how to use this equation to find percent increase. So let's try a problem where, with a concept that we're kind of familiar with, this idea of a markup. So let's say I have this problem right here, where a music store bought a CD set at a cost of $20. When the store sold the CD set, the percent markup was 40%, and I want to find the price that the CDs are sold for. So first off, let's ask ourselves the question, are we talking about a percent increase or a percent decrease in this problem? And why do you say percent increase? That's exactly right. And I really like how you were looking at the terminology in the problem, because this work markup is what's going to hint to us that we're using a percent increase rather than a percent decrease. Okay, good. So we're talking about a percent increase, and whenever we're talking about a percent increase, we have our equation right here. So it's all organized. Cool. So we're talking about a CD set where the cost was $20. The percent markup was 40%. What's another way to write 40% as a decimal? Good job. And we want to find the selling price. Okay, so now that I've written down each part of my equation from the problem, I can start to ask myself, okay, which one of these numbers is the percent increase, which one is the smaller number, and which one is the bigger number? Also, really quickly, another way to write this formula for money problems specifically. Well, okay, so we have two numbers here. We have two prices. We have the cost and we have the selling price. Now, which number do you think is going to be the bigger number, and which number do you think is going to be the smaller number? That's exactly right. And so another way to say that is that the cost is our smaller number in our equation. So 1 plus percent increase, or in this case, it's really the markup, times the cost is equal to the selling price. Cool. So you were exactly right. We're trying to solve for the selling price. We know the cost because it's explicitly told to us, and we know the percent markup or the percent increase because it's told to us in the problem. So let's go ahead and start plugging this into our equation. So we have selling price is equal to 1 plus, what's our percent increase or percent markup in this problem? 0.40 times our cost, and what's our cost in this problem? $20. That's exactly right. Okay, now I do my algebra, my fun little math. What's my first step? Multiply that number by 20. And let me know when you get an answer. And so $28. Okay, do you have any questions about this equation or this process that we just went through? Mm-hmm. Okay, good question. Let's use our steps that we learned in order to try to solve the problem. So we have 24 fish, and we have a 25% increase. And we're trying to find how many fish we have after this 25% increase, right? So did you use this equation to solve the problem, or did you use the method that your teacher taught you? Okay, good. Both methods would work. I was just curious as to which one you used. So, perfect. And when we set up our equation, how did you set it up? Mm-hmm. 30 fish. Okay, so our process looks completely okay. I don't see any problems with this method. Now, you asked a really good question that I'm really glad that you're starting to ask these questions as you're solving the problems. Does this answer of 30 fish make sense? Okay, well, here's one hint that we can use. In our equation, our bigger number is what we're solving for, and our smaller number is what we plugged in. So we decided that 24 is our smaller number, and we solve for this bigger number, which is 30. So if we're talking about a percent increase, does it make sense that our answer is bigger than 24? No? Okay, well, here's another way to phrase it. Let's say I make $100 every day and I get a 25% raise. Does the amount of money that I'm making increase or does it decrease? Mm-hmm. Here's another way to put it. Let's say I run 1 mile a day and I increase the number of miles that I run by 20%. Does the number of miles that I run increase or does it decrease? So in this problem, I have 24 fish. I increase the number of fish that I have by 25%. So is my answer going to be bigger than 24 or smaller than 24? Exactly. Right. So this is why this equation is kind of useful to be able to check. If we plug in our smaller number and a bigger number comes out, then our answer makes sense. So does that answer your question? Okay, cool. And yeah, these numbers being close can be kind of weird, but if we just stick to the game plan, everything works out in our favor. Okay. Good. So we've talked about percent increase and our equation that goes with that. And now let's talk about what if we have percent decrease? What are we going to do then? Yeah, so and do you remember which side our bigger number goes on and which side our smaller number goes on? Yeah, that's exactly right. So I'm glad you remembered that from yesterday, even though we just skimmed over it. That's awesome. But that's exactly right. Our smaller number is equal to 1 minus our percent decrease times the bigger number. It's really just the opposite of this, right? Instead of adding, we're subtracting. Our bigger number is on the right side instead of the left side. Our smaller number is on the left side instead of the right side. Okay, so now in these types of problems, typically, now not always, but most of the time, we're going to be given the bigger number rather than the smaller number. Now this may not always be the case. There are problems where we can be given the smaller number instead and we have to solve for the bigger number, but typically the types of problems that you're going to see, we're going to be given the bigger number. Does that make sense? Okay, good. So let's go ahead and use this equation to solve a type of problem. So this is actually one of the questions from your homework yesterday, and let's try to run through it now that we've learned this percent decrease equation. So a website used to sell a pair of boots for $84. It is now selling the boots at a 30% discount. What is the new discounted price of the boots? Okay, so are we talking about a percent increase or a percent decrease in this problem? And why do you say the decrease? That's exactly right. So we can use the words that are in the problem to decide which equation that we need to use. Are we using a percent increase or percent decrease? This is a question that I recommend you ask yourself for every single problem, so we make sure we use the right equation. Does that make sense? Cool. Okay, so we're talking about a percent decrease. We know that we're typically given the bigger number. We can even think about this really quickly. So if we're talking about a pair of boots that costs $84 and it's going to be sold at a 30% discount, is the new selling price of the boots going to be smaller than $84 or bigger than $84? That's exactly right. And when we're talking about discounts or a percent decrease, right, our number typically goes down. Perfect. That's exactly right. So that sort of gives us a hint that we're going to be solving for the smaller number rather than the bigger number. So let's go ahead and write down our equation. 1 minus, what's our percent decrease in this problem as a decimal? And we decided that 84 was our bigger number, right? Cool. Now we get to do some fun algebra. What's our next step in solving this equation? And let me know when you get an answer that comes out of there. Right, and this is our sale price. Which makes sense, right? When something is on sale, the cost of it is lower than the original price. This right here was our original price. This is our sale price. So our answer makes sense. So that's a good question. So typically I would say it depends on the type of problem that we're trying to solve, right? If we're talking about dollars, typically we have 4 numbers, right? We have some number, some number, some number, some number, right? because we always have these two decimal places to represent the number of cents, right? These two right here. So when we're talking about dollars, then yes, I would recommend that you put a 0 at the end. It may not necessarily be the biggest deal, but technically your answer is a little bit more correct if you put a 0 at the end. Now if we're talking about something like watermelons, like let's say I get 58.8 watermelons, then I would, when we're talking about something like this, maybe it's better to round it up to 60 watermelons. Maybe it's okay to leave it like this. But generally, I would recommend you put a 0 at the end. Does that answer your question? Cool. Okay. And so from this problem, we can actually sort of conclude, right? Our smaller number was the sales price, right? So our sales price is equal to 1 minus our percent decrease times, and this $84, this represents our cost, right? So if we're talking about money specifically or a sale, we have this nice equation where it's the sales price is equal to 1 minus the percent decrease times the cost. It's the exact same equation as up here. We're just able to sort of define these numbers a little bit better. Does that make sense? Cool. So we have time for one more practice problem, and then we'll be done for the day. Okay, so let's look at this problem right here, number 5. A suit is marked down by 20%. Find the sale price and round to the nearest dollar as needed. Okay. So we have a $300 suit. It's marked down by 20%. And what are we trying to solve for? Okay. And what makes you say the markdown? Okay, good. So we're trying to find the sales price. Okay. Okay, so let's use our equation that we're given right here to solve this problem. So we're trying to solve for the sale price. Do we know the cost? Times 300. Do we know our percent decrease? And do we know the sale price? Right, because that's what we're trying to solve for. And explicitly in the problem it says find the sale price. Good, awesome. So we've set up the problem correctly. That's usually going to be the more difficult part. Now we get to do a little bit of algebra. Sale price is equal to, how would we go about solving this equation right here? Perfect, that's exactly right. Let's check our answer really quickly. Does the answer of $240 make sense? And why does it make sense? That's exactly right.